from Zenos. I'm on the technical side. My title is there. Trent will be speaking after me. He has a few slides. He'll come up later. And basically what I want to talk today about is you need automation, right? And how we got from being an on-prem product to being a cloud-based product. And so the points there are started in version 4, and we're going to go up through version 7. I'm going to walk you through just a very basic setup of our software. And I'm going to show you some things that we automated along the way. And of course, some lessons learned. So hopefully if you're anywhere in this curve, you see what we did and didn't do, you can at least get some knowledge out of this. So, click, there we go. Okay, so two obvious questions are, of course, what is Zenos? In layman's terms, it's a monitoring platform, but it's very much more than that. We support monitoring and integrations. Let me start my timer. Basically, anything you can go out to an endpoint you can event off of, or incoming router endpoints that we have in our software allows our software to talk to your software or vice versa. Not every vendor, but a good number. ServiceNow, PagerDuty, SaltStack, various others like that. And again, getting back to the layman's term issue is, we tell you when your service is down, the worst thing you want to happen is when a customer calls in and they say, hey, is your service down? And your tech support says, what do you mean the service is down? That's how I explain it to just non-technical people, and it seems to work out well. Just saying monitoring sometimes is a bit misleading. I had one lady ask me, and she said, oh, do you mean credit score monitoring? I was like, not so much, no. So what is SaaS? SaaS is Zenos as a service. The operation team runs an instance of the on-prem software for you in the cloud, and that's the team I'm on. We do all the updates and patching and installations for you, and we basically leave you just to use the software. If you need something done, put in a ticket, make a request, we'll service that and get your instance back to you so you can use it. We kind of take all the hard work out of your hair, so to speak. All right, so we're going to start with the Zenos 4.2x, and it's a basic on-prem product. It was released in September of 2013, and this is just a crude diagram of a LAN where you have a host that will run our software. You have a collector host that will gather information, and then you have an app or a server. It could be a switch, a router, pretty much any device that we can talk to, you're going to pull that for information. Again, this is 2013, so it's traditional Unix daemons. You installed packages into /opt into a home directory. Everything we're accustomed to in the old school of thinking. All right, so, like I said, basically the collector piece would sit on the network. It would pull the application, server, whatever device you'd like. And we have some specific plugins for specific devices that give you some pretty deep data, depending. Or you could just go with something as generic as SSH or SNMP. Once it's collected the data, it ships it over to the host, and then it's graphed and stored into the database. You can do eventing, alerting, anything you want to do there. So like I said, this is very old school. In this era, this is before DevOps became mainstream. DevOps is probably just like ending its trailblazing phase at this point and just starting to be cemented in the mainstream, but it wasn't really there yet. So the next piece we did to evolve to the cloud was we took, I don't know, can you see that? The main server itself, and we took that and we uplifted it into the cloud. So each customer got their own subnet and they had their own server, and so the collector piece lived on the land, still in the customer's data center, and that's where we got the name Zenos as a service. At this point too, we realized that it would be easier if we could productize the collector piece, and we made an OVA, which was an appliance. You could just download the OVA, install it, and be up and running fairly quickly. the automation we have in at this point was that we're using VMware Studio. Rebuilding the collector for a new version was fairly easy at that point. However, VMware deprecated the product a bit later, and that gave us some challenges later on down the road. The other thing is that we obviously realized we need to secure the communications between the remote collector piece and the mothership, shall we say. So we established an open VPN connection. There's a client server, obviously, and there's a collector key mechanism. Think of it as a license key. You download the collector appliance, put in the key, and it knows which server to dial into and make the connection. At this point, this was done by a predecessor. He built everything in Chef, and it worked fairly well. The team at this point was still pretty small, and like I said, he left, he kind of took that knowledge with him. So that was a point that was going to be an issue later on in our journey to being cloud. And so pretty much what we did do is this, the DNA of this, where there's a collector appliance, there's a VPN server, you have your own instance. This DNA is kind of stuck around, and it's still the way we do certain things even today in 2018. So that was 4X. Now along came 5X, which was radically different. And I started at Zenos probably maybe 6-7 months after 5X came out. It came out in February of 2015. And this release was a very significant change from the earlier product. We were no longer a traditional Unix daemon running on a shared host. So basically, the first thing was that it was now a cluster. We had 3 hosts, and the hosts themselves were not uniform. There's a master and 2 worker delegates. So that's another point in the automation to consider when we get around to that. But the point for doing this here was horizontal scalability. We want to be able to just add, in theory, unlimited worker nodes and just keep building and building more data that you could put into a single instance. Whereas previously you had to fire up a second instance once you reach a certain limit. So the other thing to achieve this is Docker. So engineering chose Docker to implement this. And containers, of course, are obviously a big difference. And they're being spawned on one of 3 hosts, depending on which service it is. And so the question was then, how do we automate this, since it was so radically different from the previous version? At this point, the ops team is on the learning curve for both the new version of the product, Docker, clustering. There's a lot here to consider before we can just start running 5X in the cloud, which customers were already asking for. So obviously, like I said, the complexity has been increased, and the cluster nodes are a bit unique. So so we're still basically an on-prem product at this point, and we're running it in the cloud. There are multiple things we could automate for the installation, but there are still several steps that we had to manually do. Like one of them is to go into the GUI and specify the SNMTP server to email alerts out. And there's just a couple of time-consuming issues like that we kind of had to live with. Like I said, again, the collector itself, we had to rebuild this from scratch. VMware Studio was no longer viable. And the new version of Zenos ran on CentOS 7, whereas the old version ran on version 6. So that gave us some compatibility issues as well. So the needs to get this up and running in 5X in the cloud, just like our 4X that was available, we had to fill some gaps. And so we had to be able to deploy the host in the cloud using their API calls. We need to reconstruct the collector, like I said, with the open VPN and the collector key mechanism. And we needed to be able to turn these around in a reasonable amount of time. We determined that about 2 business days would be a reasonable amount of time. We would like for it to be faster, but there were some challenges. So before we started moving forward, we wanted to at least gather a few pieces of information, and that the basics were what does a 5x installation look like? Our product is a bit configuration heavy in the config files, and so we needed to find a basic working model for that, and figure out what size hosts we wanted to put it on, what software packages, what kind of troubleshooting tools to include on the servers. And once we got in there and needed to do some troubleshooting. The API calls we had to figure out, how to set up a host, how to add a disk, how to add an IP address, security groups for the firewalling. All of that had to be accounted for, DNS entries. And then we needed to find a way to deploy this. We needed a script where we can run a command. Basically, the ideal situation was we had a deploy script and/or mechanism with a customer name, and it did everything up until our last couple of manual steps at the end. And one of the things, obviously, we needed was that if it bombed out in the middle of the script, we'd be able to start the script over, and it would skip over the steps that it had already done and continue where it left off. So the state of the tools at this time was not the greatest. We had some issues with early versions of some of the HashiCorp tools. The DevOps toolbox has grown up a lot since this period of time. One of the things that wasn't really a thing per se was orchestration for Docker containers, and Zenos Engineering actually created a product called Control Center to handle that across the 3-node cluster. That's still part of Zenos today. So like I said, the Hashi tools were around. They're a little bit dicey, and depending on which method you used. Like it worked pretty well for creating OVAs for VMware, but if you try to do a Hyper-V appliance, it was just pure torture. At this time, I wasn't even familiar with Salt, and didn't even know what Salt Cloud existed, and I really wish I did. So it's easy to look back, though. The perception here, we had a small team, and there were a limited amount of hours in the week, of course, and the perception for us, at least, was that learning a Chef, a Puppet, Ansible, SaltStack on top of what we need to know to get our product up and running in Docker and et cetera. We felt that, myself specifically, that we didn't have time to investigate it. We spent a little bit of time looking at it, and it seemed like that anytime we tried to find an example, it was the most complicated example we could find. And there was no simple answer from what we were finding. And perhaps this was only a perception thing because of the timeline pressure we were under. So the interim solution was that we used Packer to build a collector. It worked out pretty well, actually. And we decided that since we couldn't, the mechanism for importing VMs into the cloud wasn't where we wanted it to be. It wasn't stable enough. We decided to just hand build the images for our software and to run just a specific base OS with packages in our software, and we would just, for the time being, maintain that by hand. So ultimately what we did was that we created a homegrown deployment tool, which is still around today. And it's just a very simple script that reads CVS files, CSV files, and it's just a series of commands, do this, and then if you run it again, because it bombs out, it knows which steps have completed, and it just picks up where it left off. And that was all we needed at the time. So, obviously, during this painful process, we learned some lessons along the way. I want to share those with everyone, so hopefully you won't make the same mistakes. Number one, hand-created images are bad. If you have one person that updates them, they really become a bottleneck. And if there's some radical changes from version to version in your software, that one person has to learn what the changes are and then go update the image. So don't do that. So the lesson here is that SaltStack and HashiCorp, the tools that they have available, are definitely your friends. Temporary solutions are rarely temporary. Like I said, the solution we built is still being used today up until the cloud entry that we're launching. And if you're going to figure out what you need to do along the way, go ahead and do it in your tool, like a Packer or a Salt Cloud. The approach we initially took was to create a bash script. Okay, these are the commands I need to stand up a host, to add an IP address. And it got us along quickly, but in the end, had we done it in the tools themselves, we'd be done once we got to the end. So don't be afraid just to sandbox. Because otherwise, if you do it all in a bash script, you're going to get to the end, and now you have to port it to like a Packer or a Salt Cloud or a Salt State. And it's actually extra time. It may not seem like it at the beginning if you're not familiar with the tools, but it definitely is. So scale. Keep scale in mind when you're doing things, when you're trying to find a solution to a problem. So there are times when it's perfectly acceptable to open an iTerm, split it into 4 panels, jump into a couple machines and run a command. That's fine. But it's not always the best solution, clearly. I mean, we have a customer who has 10 delegate nodes and another customer who has 50 collector appliances, which is small scale on the Salt scale. But clearly, you couldn't use iTerm for that. You're going to need an automation tool. So 6X, which came out last fall, is pretty much where we consider it to be the Salt Cloud era, the SaltStack. The team had started poking at Salt, and we were starting to get some basics down pat, and it was really, really helping. This was in a time where we had grown, I think, about 225% year over year. So we didn't have much time on our hands to do anything, and any piece of automation we could use, obviously was a great benefit to us. So, like I said, in addition to expanding the customer base, we were also fortunate enough to be able to expand the ops team. We added a dedicated DevOps person. He actually came over from our IT department, so it was nice to see opportunities within the company for someone to move over. He couldn't be here this week, but hello, Justin. So his focus was the automation and configuration management, and SaltStack was the choice, of course. So like I said, we just use pillars and grains. We're able to standardize our configurations. The Jinja templating system is just pretty much a godsend. You can just pull the information out, plug it in for that host, and just go. And you don't have to worry about it. You can actually do 50 collector hosts at once. There are maintenance windows that I've done where if I didn't have Salt, there was no possible way that I could have done the maintenance on that many hosts in that short 2 or 3 hour span. All right, so like I said, so we have the high state is obviously the end goal, but for us, because we're still ramping up on the curve, it's an evolving process. We find our best practices are we see something that works, it doesn't work, and we'll add another step to the Salt state. We'll say, it would be great if we had this. Okay, great, and we add it. It's kind of ever evolving. I don't know that it will actually reach an endpoint for that, but it's good, and it helps us to tame our infrastructure. So I'll give you an example of what we're doing with Salt, and this is a bit painful to do it by hand, but using Salt, it's great. And it's a bit high level. All right, so click DNS Resolution. We have a customer, and it's the same diagram as you're seeing with these items down here at the bottom. These are all, of course, in the customer's data center on site. And they may have, for example, something called host.local. It's a private domain, and only this DNS server in green will actually be able to resolve that name. And the internet, of course, can't see this server because it's blocked. So all we have to do is plug in the DNS information into the collector appliance, saying use this DNS server for this domain, and you can resolve the name. It's a host.local. And so anytime, any process that's running on the collector, it'll be able to refer to the host's configuration, because it's just a Docker container, go out to the DNS server, and yes, it will find host.local, not a problem. But the issue is the DNS resolution for host.local does not yet work in the containers running up in the cloud. It's a very distributed nature application. And so what we have to do is we end up having to install DNS mask on the cloud servers, and we have to tell it where to forward the request for host.local or anything in the .local domain, so that the containers running in the cloud can also utilize the DNS server on-prem via the proxy, and they're able to resolve host.local. And so once it's set up, obviously host.local passes, and we're able to put everything into our monitoring infrastructure by host name instead of finding it by IP address, which is very, very tedious. Now, with Salt, all we have to do is plug in the information in the configuration of the appliance, and there's a state that goes by, and it recognizes that etsyresolve.conf has a domain name in it, and it goes and transfers that domain name to the DNS mask configuration up in the cloud, and that's just one of the pieces that it does. So don't do this by hand, because it's really unmanageable. And the DNS mask piece is just one of about 50, I think it's about 53 steps that happen when we turn up a new collector, the collector high state essentially, so that it checks Docker configuration, IP addresses, IP tables, firewall rules. There's a number of things that it checks, and it's very hands-off. Consistency is the goal here. It's not humanly possible to run through a 50-point checklist on every single host. You will lose your mind. And what usually happens is you get to a step, you think you've done it, someone walks in the office, and then you come back to it after being distracted, you're like, oh yeah, I did that step, but you didn't. This helps us immensely with consistency that we just don't have to worry about. We run the high state, it takes maybe 2 or 3 minutes, and it comes back with any errors, usually none, and we're off to the races. It's very, very hands-off at this point. So that brings us to Zenos 7, and Trent's about to talk here in just a moment. So I'm a technician. I like version numbers. To me, it's Zenos 7. The branding, of course, is Zenos Cloud. It's a brand new offering, and they've taken what was stumbling steps that we've noticed over the past couple of years, and they've put it into the product, re-engineered so it's much easier to automate. It's fast to stand up, and like I said, the ops team's best practices have gone into that, and we're evolving that as we go. You can only put in a little bit at the beginning in the initial release, but step by step, we're going to get it all in there. And I'll give you a sneak peek before Trent starts talking. So that's the UI. It's very nice. Zenos Cloud, the new logo. And Trent, you're ready to go.
Thanks, Ron. Sorry. Hey, everyone. I see a lot of familiar faces from coming by the booth, so I apologize in advance if I'm telling you things that I've already told you more than once this week. There is no Zenos 7, so don't ignore what Ron said about that. It's called Zenos Cloud, and the reason that we went with the strategy of Zenos Cloud is in the interest of software-defined IT operations. Sometimes when people see this or hear this, they just think, oh, they're just making crap up, but that's not what it is. Software-defined IT operations is a model-based, policy-driven, declarative, programmable abstraction that separates the underlying infrastructure from the needs of applications and services. What does this mean to the business? And again, this might be the part, you want to capture that, sir? What does it mean to the business? I'll get to the graphic, and this is the part that some of you have gone through in the booth with me. This is what Zenos has always done. I'm going to talk about what we've always done and then what we're doing with Zenos Cloud. When we released version 5, that is when we took our first step towards software-defined IT operations. And what it meant was starting with data collection. We're collecting metrics and model data. This is the one thing that Zenos has done over the years that nobody, it's not really a topic of debate that some other vendor is better at this than Zenos. This is the Zenos bread and butter. This is where our domain expertise is, and that is understanding every single system that is a component in an IT service. And so over 10 years, we've built up a library of Zenpacks. We call them Zenpacks. These are plugins that go out and get the information from the systems in your environment. And this has been completely agentless prior to Zenos Cloud. What that means, and I said metrics and model data, it's important to understand this distinction. Lots of systems are collecting metrics and they do it in different ways, and it sounds like anybody can collect metrics. The tough part is the pull method, where you go out and get that data and you understand the systems that you're getting the data from, but it's also collecting model data. And what model data is the data that tells us how that system is connected to other systems, how it's dependent upon other systems. This is something Zenos does that no other vendor does. This is what allows us to build this real-time model. We call it a real-time model. If you stopped by the booth this week, you would have seen in the demo, there's this full topology map that we have in the interface, and it's real-time. If you move a VM from one hypervisor to another, if something changes, it updates in real time. This is what is unique to Zenos, is having the insight of how an IT service is constructed and therefore what things can impact other things. This allows you to do two major use cases. One is a service is degraded or down, let me root cause that. And again, when you have the whole topology map, you have some issue, the software walks the map and tells you with 98% confidence, it's this thing over here that's causing this problem. On the flip side, before there is some service impacted, if there is a disk spinning funny in some storage array or some load balancer is having an issue, it can proactively tell you, these are the services that are probably going to be affected if you leave this unchecked. So you can then do predictive and proactive actions to prevent IT service interruptions. So the third thing that we have been doing for years now, and this is where SaltStack comes into play, is we have these integrations with other ITOM systems, and that includes incident management like ServiceNow, it includes CMDB, it includes orchestration and provisioning. And so this is not new. We've been doing this. This is our third time to sponsor here at SaltStack, and they come to our user conference. We have customers with production environments. We have our own SaaS backend production environment where we've integrated SaltStack with Zenos software to automate remediation. When there is some issue that Zenos becomes aware of, we send that notification to SaltStack. They can then kick off some orchestration provisioning activity that remediates that issue. Then it can be unwound in an automated fashion as well. So that's what we've been doing. Now I'm going to tell you what's different with Zenos Cloud. I talked about Zenpacks and how that is the bread and butter of Zenos. This is what we've added with Zenos Cloud. We've created this, and I don't know if anybody knows this, but it didn't happen on purpose, but our little diagram looks like a TIE fighter, Darth Vader's TIE fighter from Star Wars. So we call this the TIE fighter diagram, but it has nothing to do with Star Wars. But all of these things coming in from the left, there is this data plane on the left side now that is able to ingest not only the metrics that and model data that we're going out and pulling, but we can take push metrics from any source. We can take log data, event data, now agent data. So I said before that we were purely agentless. Now we can take agent data as well. This is all then fed to an analytics engine that is in the cloud. And that's why this is called Zenos Cloud. This is a SaaS platform that's on GCP. If you're going to collect this much data, you have to have a SaaS backend. You have to have a cloud platform where you can do machine learning, where you can do data streaming. What's different here is the model. Again, we're taking explicit model data where systems have told us explicitly how they are connected to and dependent upon other systems. We're not inferring this from logs and events only. We're taking model data, informing machine learning algorithms, and running analytics that way. Ludicrous scale, a Spaceballs reference. And then it's multi-tenant and API to the Google Cloud platform. So you can get the data in and get the data out. Now we have intelligent dashboards, and even if you didn't stop at the booth, if you walked by, you probably saw the dashboards that we have now. These are dynamic views. This is faster troubleshooting is what it means to you. Chat ops style collaboration in the dashboard. Subject matter expert crowdsourcing allows it to be more informed in its dynamic adaptations. And then we've got, this makes it more suitable for both ops personnel that are actually on the front lines as well as for business personnel. And the last thing is the ITOM automations again. That hasn't really changed, except now the insights are more specific, more accurate. It enables more accurate automated remediation. And this is what we call the Intelligent Operations Management Platform. I only have 2 more slides, and it's just showing you guys some screenshots. What you'll see is the main card over on the left, and you can choose what goes in the main card slot. All of these things are, this is telemetry coming from systems that are a part of that IT service model that we created. You can see things like Tomcat, you can see UCS chassis, UCS blades, you can see storage arrays, you can see services running on operating systems, CPU temperatures, memory capacity, etc. This is all collected together not in the topology view. This is the let me see the metrics from these things view. And so you've got anomaly detection now. These smartly ordered dependencies, the system learns what matters more and tries to bubble those up to the top. But you can also influence this by voting up and voting down. This is the subject matter expert machine learning. This is how you inform the thing what is more important. You influence your own the most, but because it's a multi-tenant platform, there are weighted meanings to everyone's votes. So when you first turn Zenos Cloud on and go to this dashboard, it's already been influenced by everyone else that has voted, and then you can overrule and move things manually yourself so that it's the way you like it. Not everybody works in a bright room, and so that you can do the light color or the dark color. This is the same dashboard, and I'm just showing you a couple of other features. You can choose any one of these things and drill into them and go through the specific data points on each one, the events and alerts from each one. You can also use this time slider. This is one of the most interesting features, I think, for Zenos Cloud. If something happened 3 days ago, you realize that a service has now been degraded for 3 days and you want to go back to that time, you can take this time slider and drag it back. We typically keep 30 days, but that's configurable. And you can go back and see the status of every one of these components, the measurements from each one at any given time. You run your mouse across it and it slides the line across with each one. This allows you to do troubleshooting even in environments where you have ephemeral systems like containers and microservices, because a container that spins up for 1 minute and is gone is no longer in a static dashboard. You drag this time slider back, you can see which containers were alive at that time, and you can see what the metrics were coming from that container at that time. And then there's the chat ops feature. This allows you to, as a team, add your insights and let the other teams benefit from notes, so that this becomes a repository so that you don't have to go searching for information or emails or or Slack, which is what we do prior to this. I'm going to leave time for Q&A. The last thing I'm going to show you is we do have an upcoming webinar with an industry analyst, the 451 group. The topic is trends in machine learning, AI, and cloud. The easiest way for you to get to it if you're interested is just go to the Zenos.com homepage and scroll down just a little bit, and that button's there. And this webinar is next week. So I just want to let everyone know that. And also, if you would like to see a demo, the easiest thing to do, first of all, if you just come up here afterwards, we can set it up, or you can request a demo from the website as well. We gave a lot of demos this week and had a lot of good interactions. And so if you guys missed that opportunity, just give us a shout either right here or go to the website and ask for it, and we'll do that. And now I will stop talking and allow you to ask questions of either one of us if you've got them.
Check. Okay. So
we must have given just the exact right information.
it's the food coma, I'm telling you.
It's the food coma.
Yes,
Yeah.
absolutely. All right. Well, anyway, thanks for your time. Thanks for showing up.
Yeah, thank you very much.